Hi, and welcome to the second video for section 5.4. So at the end of the last video I said we'll wrap up section 5.5. We're not quite there yet, almost there. First we have to wrap up section 5.4. This is the second of two videos. And in this video we're just going to look at what is known as the mean value theorem. Which you will also see this abbreviated MVT. And this is for integrals. And it says the following, that if f is continuous on the closed interval AB, there exists a number C in the interval AB such that f of C is equal to 1 over b minus a times the integral evaluated from a to b of f of x dx, which we can sort of rewrite this. If we multiply both sides by b minus a, what happens? It cancels out here, and we multiply it by this. So we can say really that this integral from a to b of f of x dx is the same as the function evaluated at some point within the interval times b minus a. So it's basically just telling us what is the average value of this integral. So let's look at an example. So for f of x is equal to 1 plus x squared on the interval -1 to 2, the mean value theorem says there's a number C such that ST. So if we're using the mean value theorem, it says what? The integral from a to b, so from -1 to 2, of this function 1 plus x squared dx is equal to the function evaluated at some point C times b, which is 2, minus a -1. So if we wanted to know what's the mean value of this integral, what's the average value of this integral, it's this, we can determine what the point is here at C in order to figure that out. So let's do all these pieces we can and then try to solve for our value C. So this guy here, if I take the integral, what do I get? I get x plus 1/3 x to the third evaluated at 2 to -1. So if I plug this in, I get 2 plus 2 to the third power is 8, so 8/3 minus -1. -1 to the third is -1, so minus 1/3. And this is why I told you use these parentheses. Because what do we have? Minus a minus, minus a minus, so it's going to be plus. So if we simplify this, get rid of all the parentheses, change the denominator 3, we get what? We get 6/3 plus 8/3. Negative negatives is positive, so plus 3/3. Negative times negative is positive, so plus 1/3. So we get what? 14, 17, 18. 18/3, which is equal to 6. So the left side of this equation is 6 is equal to 2 minus a -1 is like 2 plus 1. So it's like 3 times f of c So that means what? F of C, the average value is 6 divided, so if we divide both sides by 3, is equal to 2. So that means what? That means if now f of c, so if f of x is 1 plus x squared, if that equals 2 when our value of x is equal to c. So this means 1 plus c squared, I'm plugging in x, plugging in c, anywhere I have an x, has to be equal to 2. So I'm trying to find out here what number c actually gives me the mean value of this integral. So I subtract 1 from both sides, I get c squared is 1. So that means what? That means take the square root of both sides, so c is plus or minus 1. Well, this interval goes from what? -1 to +2. So in this case, we actually have two numbers that if I plug in 1 or -1 into the function, it gives me what the average value is, which is 2. So our number c is plus or minus 1 gives us the value, the point at which we get the mean value of this integral. So that's it. Nothing too fancy, just using what is the mean value theorem, what's the equation that's generated by it, and then how can we apply it to determine what is our average value, which in this case is 2, and where does that point occur? Well, we just set up the function equal to that value and solve for c. So that's it. That's the end of video 2 for section 5.4. Come on back, we'll do section 5.5, which is the last section that we'll be covering for this semester.